Okay, so this video is for Physics 12 students at James M. Hill. We're working on three types of problems that imply our forces breaking up into components. This is a type 1 problem. A 55 kilogram snowblower is being pushed along the ground at an angle of 35 degrees to the horizontal with an applied force of 175 newtons. Very important to set up your coordinate system. So there's mine right there. Be very consistent to what we've been using in class. Horizontally is called x, to the right is positive, left is negative, vertical is called y, up is positive, down is negative. So we want to find the applied force in the x direction and in the y direction. Applied force in the x is going to be the magnitude of the applied force, cosine of our angle. So I'll just write the formula there, cosine of theta. Applied force is 175 newtons. Cosine of 35 degrees. Make sure you're in degrees in your calculator, not in radians. That works out to be 143 newtons. In the x direction, it's positive, so it's to the right. The applied force in the y direction, magnitude sine of the angle. So here's where you have to be very careful. This object is pushed. That means the applied force is going to be downward. It is going to be a negative value because our direction for down is negative. 175 is the magnitude, sine of 35 degrees. That works out to be about negative 100. Very important to have that negative indicating the direction. The magnitude of the applied force in the y direction is 100 newtons, but it doesn't hurt to write the direction down in case you need it later and you won't forget it. B asks us to calculate the normal force. This is what's a little bit different from grade 11. Here we have to consider that the net force in the y direction is the sum of all forces. Redo that. In the y direction. Didn't have to do that in grade 11. We do that now in grade 12. So F net in the y direction is equal to the force of gravity, that's acting vertically, plus the applied force in the y direction, that's acting vertically, and then the normal force is also acting vertically. Our net force in the y direction is 0. This object is not lifting off the ground, it's staying at ground level. Force of gravity is mg, be negative mg, force of gravity, mass times acceleration of gravity. And then I'll just write here plus force applied in the y direction plus force normal. I'll fill in our numbers. It's negative 55, 9.81. Don't put both the force and the acceleration of gravity negative, just leave the whole term negative. Force applied in the y direction is negative 100, plus the normal force is all that's left that we don't know. So this works out to be negative 540 minus 100 equals your normal force, plus your normal force. Solving for your normal force gives us positive 640 newtons. Should be positive, it's directed upwards. C asks us to find the force of friction. So force of friction is going to be the coefficient of friction times the normal force. We could also consider all the forces acting horizontally, but we don't know what the net force is yet, or we may not be able to calculate that till later on. So our force of friction is our coefficient times our normal force. So force of friction is mu 0.19, normal force is 640. Force of friction comes out to be a magnitude of 122 newtons. So you got to remember that that is always going to act opposite the direction of motion. So D, do that over here, except I'll write D, not B. D is finding the net force. Now net force in just the x direction. So still the sum of all the forces, but just in the x. It's F net x equals applied force in the x direction plus the force of friction. So that equals 143 minus or plus a negative 122. Very important that you remember the force of friction acts in the opposite direction of motion. So the net force works out to be 21 newtons. And finally, down at the bottom, E asks us to calculate the acceleration. And this is only going to accelerate in the x direction because the net force vertically is 0. So our net force is also equal to mass times the acceleration in that same direction. Newton's second law, 21 equals 55 AX. Divide both sides by 55 and you get 0.38 meters per second squared is the acceleration in the x direction.